Alright, hello everyone. So today we are going to learn about simplifying rational expressions. First, what is a rational expression? Well, it's an algebraic expression, so that means it has to have variables in them, okay, that can be written as a quotient. Now this thing right here basically means fraction, okay, as a fraction, something is a numerator and a denominator of the two polynomials. Then that is a crucial part. So you're writing a fraction, but the numerator will have a polynomial like x plus 1, and the denominator has a polynomial, in this case is a monomial. That's acceptable. Or some other ones, x squared plus x plus 2 divided by 2x cubed minus 1. So these are all examples of polynomials. Now I put an important note here for you to make sure that the only way a rational expression can be defined as a rational expression is that the numerator and the denominator, both of them, they must be a polynomial, and of course monomial is acceptable as well. All right? All right, examples of not a rational expression. So for example, square root of x divided by 2 plus x, that is not a polynomial and a rational expression because of the square root. A polynomial doesn't have a square root. A polynomial has exponents or integral exponents 2, 1, 3, 4, 5, not a negative exponents, positive exponents as well, right? Another one will be something like this. It will be, let's say, 3x plus y squared divided by x to the negative 1. That is not, actually let me add that to it, x to the negative 1 plus 1. That is also not a rational expression. Sometimes we have to evaluate a rational expression. Let's look at an example. So we're going to evaluate this expression, 5x plus 2y over x, and for x and y, x is negative 3, value of that, and y, the value of y is 2. So what that means is that you just plug these numbers back into the rational expression and find the actual value for it. All right, so x is minus 3, so wherever you see x, you have to put in minus 3, and remember bet maths. So we have 5 times minus 3, because 5x means 5 times x, plus 2 times 2, okay, y was 2, so 2y is 2 times y, divided by x, which is minus 3. And let's do the math on that one. Minus 15 plus, so 5 times minus 3 is minus 15, plus 4, 2 times 2 is 4, divided by minus 3. Let's simplify. That would be minus 11 divided by minus 3, and we can leave it as a fraction, but we can never negative divided by negative, we can deal with that. That's positive, and the final answer is 11 over 3, and that's how you evaluate that expression. Okay, so we're going to use the same x and y. So x is minus 3, y is 2. This time we are going to evaluate this new expression, x plus 4 over y minus 2, or divided by y minus 2. So let's plug numbers in. Here it is, minus 3 plus 4 divided by y is 2, 2 minus 2, and we get 1 divided by 0. So 1 over 0, but 0, if you take out a calculator, what is something divided by 0? Well, it is actually undefined. That means it doesn't have a value. All right, so, and because of that, we have to be very careful that whatever value that we use for the denominator doesn't make the denominator 0. All right, and that is the important piece of any rational expression we have to watch out for. All right. Okay, so now we are going to talk about non-permissible values, just basically following the 1 over 0 that makes this whole fraction undefined, therefore makes the rational expression undefined for values y equal to 0. So non-permissible value makes the rational expression undefined, and only happens when the denominator of that rational expression is 0. Let's look at an example. Alright, so we want to find out the non-permissible value for this rational expression. Now the only thing we have to look at first is x. Alright, the denominator. So this is the denominator. We're going to look at the x. For what values of x makes that equal to 0? Well, when x equal to 0. That's the non-permissible value, because you'll get 4 times 0 plus 1 over 0. We don't really care about the numerator, but let's do the math on that one. So that would be 4 times 0, 0 plus 1 is 1, 1 over 0 again, and that makes the entire thing right here undefined, the entire expression undefined. Okay, and that is the non-permissible value. So the non-permissible value is x equal to 0, where x, in fact, basically another way of writing is x cannot be 0 if we want to make this expression defined. Every other values will work except x. So that is the non-permissible value, and I call the non-permissible value NPV. So the NPV is the non-permissible value. Okay, what is the NPV for the new expression? 3x squared plus 2 divided by x minus 1. Alright, to find the NPV, you're only going to focus on the denominator, and you're solving for x. That's how you're going to get the NPV. So you're solving for the variable to find out what variable cannot be. Alright, so x minus 1, so we know that denominator cannot be 0. So x minus 1, you set that equal to 0, because we know that it cannot be, but let's set it equal to 0 so we can find what x is, and then we exclude that. So x minus 1, the denominator, when it's 0, that makes it undefined. So let's find out what x is. So that would be x equals to 1. That means x, it is the non-permissible value. So that means, really, to write it properly, x cannot be 1 if the expression, we want the expression be defined. Okay, so x cannot be 1, or x is the NPV. X equal to 1 is the NPV.